Okay, let's take a look at this example and answer these questions. For the ruled wheel example, are T1, T2, and T3 mutually exclusive? Well, we know the condition for being mutually exclusive is probability of T1 intersection T2 intersection T3 needs to be equal to 0. And that is correct, because if you take a look at the ruled wheel example, there is no intersection between the first 12, second 12, and third 12. So that probability is equal to 0, and we basically say yes, the condition is met. What is the probability of T1 union T2 union T3? Well, union means all the outcomes in those three events together. Well, T1, T2, T3 is 1 through 36. And remember, don't make this mistake. We have 38 outcomes in the sample space. So we have 0 and double 0 as well. So that probability is going to be 36 over 38. Is T1, T2, and T3 forming a partition of the sample space? Well, we know the partition has two conditions. First, probability of T1 intersection T2 intersection T3 needs to be equal to 0, which means they have to be mutually exclusive. Well, that condition is met. But at the same time, probability of T1 union T2 union T3 needs to be equal to 1 if they want to be a partition. But that condition is not met. So we say no. Remember, these two are the conditions for being a partition. And the last question is red, black, and green a partition of sample space? Well, they are, because they pass both of those conditions. Probability of red intersection black intersection green is equal to 0. They don't intersect with each other, and their union is the entire sample space. They have all the 38 outcomes in their union. So both of those conditions are met, so we say yes.